Okay, good. Yes. So yesterday we were looking at the combination method. Okay, the combination
Yes,
method for the binomial theorem. Binomial theorem. Okay. The way your book put it is going to be difficult for you to understand. Okay. So what I have done is that I've started from the combination method, and I'm coming backwards. I'm coming backwards to the binomial theorem part, the 191. I'm coming backwards to one. I started from 195, page 195. So I'm coming backwards to page 191, and then maybe 194. I'm sure that one will make sense. It will make it clearer than how the book puts it. Okay. So if I was saying that if we have something like this, a plus x raised to the power n, it will be equal to, okay. So the first term, what will be the coefficient? What the coefficient for the first term? How do we find the coefficient for the first term using the combination method? Later.
n combined with 0.
We call it n combination 0. N combination 0. Okay. So n combination 0, a will start from n. Okay. The b, there will be nothing for the b or the x. Okay. Then move on. What's the coefficient for the second term? You know that. Another one, the coefficient for the second term. You have to mute your mic for us.
N combination 1.
Yes, n combination 1. Okay, so our a will reduce by 1, then our x will be 1. Okay. Answer to the chat area. Then we'll keep going. The next one is going to be what? N combination 2, right? Our a will reduce by another 1, and then our x will increase to 2.
Increase by.
Right? Okay, so we'll keep going. We are going to keep going till our last but one term. Our last but one term was what? If you remember, our last but one term. Let me put the 3 dots there. What was our last but one term? What was the coefficient for our last but one term? N combination.
N combination R.
Yes, N combination R. Okay, N combination R. Our A was raised to the power N minus R, and then our X was raised to the power R. Please, you need to keep this. You need to keep this off head, because that's what you are going to use to expand. Okay, so for what you are going to do today and maybe on Friday, you need to keep them off head. Okay, but they follow a pattern. Because they follow a pattern, you don't necessarily have to keep everything in your mind. Okay, just follow the pattern and you should be able. The last, what's the coefficient for the last term? What was the coefficient for the last term?
N combination N.
N.
Yes, N combination N. Good, N combination N. Our A, by that time, our A will be done. So to left with what? X. Our X will be raised to the power N. Okay. So this is where we ended. This is where we ended yesterday, right?
Yes.
Yes, good. How many people have joined now? Okay, so now many people. I go to you there.
Yes, I'm there.
Joe. Okay, thank you, Joe. Yes. Do you remember what I said? N combination R. What's the formula for N combination R? Will you remember the formula for N combination R? Will anybody remember the formula for N combination R? Do you remember?
Sir, please.
Says N divided by.
Yes, N factorial divided by
N minus R factorial.
R
factorial.
Good. Yes. So this is the formula for N combination R. N factorial over N minus R factorial. Are you okay? Are you there?
Yes, please.
Yes, please.
So based on the combination method, I'm trying to do N combination 0, N combination 1, N combination 2. Okay, are you there?
Yes, please.
Yes.
I'm using it to bring another binomial theorem formula for you to know. Okay, so we are going to do N combination 0. Okay. But before I explain the n combination 0 very well to you, okay, I just want to use a typical example. If I have something like 7 combination 3, 7 combination 3, what is it going to give me? What is it going to give me?
7 factorial
7
divided by
factorial divided by
7 minus 3 factorial.
yes, 7 minus 3 factorial.
3
3
factorial.
It's 3
factorial.
factorial.
Good. Okay. So it's going to give us what? 7 factorial over 4 factorial 3 factorial. Are you okay?
Yes, please.
Okay.
Yes,
Now this 7
please.
factorial is the same as what?
7 times 6 times 5 times 4 times
Yes.
3 times
7
2
times 6 times 5. Okay. Okay. Now times 4 times 3 times 2 times 1. How can we write it in factorial form? Times 4 times
Times
3
4
times 2 times
times
4
4
factorial.
factorial.
4 factorial. Yes, this is what I wanted you to do. Okay, so you could do the 4 factorial times, then the 3 factorial will be 3 times 2 times 1. Okay, so that this 4 factorial can cancel this 4 factorial. Okay, and then this 3 and 2 cancel the 6. Okay, so that will get what? We'll get what? 35, right?
Yes, please.
35. Are you following?
Yes, please.
Yes.
Sinam, are you there?
Mr. Nketia, please, what did you just do when you canceled the 4? And you canceled 6.
The 3 and 2 cancel the 6.
6.
Yes. Are we okay? Are we clear?
Yes, please.
Yeah. Yes, please. Yes.
Okay. Now I'm coming to do the n combination 0. Okay. I need you to take your time and look at something. The n combination 0. So now n combination 0 is going to give me what? But before that, I want you to hit 0 factorial. What do you think 0 factorial is? Remember one day I came to class and I said that if you shout 0, you get 1.
Yeah.
1.
Those of you remember 0 factorial is 1. I remember I came to your class one day and I said if you shout 0, zero exclamation, you get 1. Some of you didn't understand. Today this is the explanation of what I said. They understand. So 0 factorial is the same as 1. Okay, 0 factorial is the same as 1. There's a video on YouTube explaining why 0 factorial is the same as 1. It's one of the most watched math video on YouTube. Why 0 factorial is the same as 1. But that wouldn't be our focus for our class. Okay. So we are going to get n combination 0 is going to give me what?
N factorial.
N
N
factorial
factorial over
divided by
N
into
minus
brackets N minus 0
0
factorial.
factorial.
n minus 0 factorial.
0
0
N minus 0
factorial.
factorial. Okay, so we are going to get what? N factorial over what? N factorial 0 factorial.
0
Okay.
factorial.
This n factorial can cancel this n factorial. 0 factorial is what?
1.
1. So you are going to get 1 over 1, which is going to give me 1.
1.
Is that one clear?
Yes, please.
Yes, please.
Francis, Sean, Adam, Sinam, is that one clear? Akutu?
Yes.
Okay, good. If it's clear, then we can go to the next.
Yes.
Okay, so we are going to do yes.
Please, why is it 1 over 1? If
okay,
only the denominator.
This n will come here 1 and come here 1. Okay, this n factorial will come here 1, come here. It's because I didn't write it, that's why I didn't see. That's why I think most of the time you can write it down. Okay. Now somehow would have assumed the top there is 0. The top there is not 0, the top there is 1. Okay. So now let's do n combination 1. Okay, so now we are doing what? N combination 1. N combination 1 is going to give us what?
N factorial
N factorial
over
over
n
over
minus
n
1
minus
and
1
1
factorial.
factorial.
Factorial
1
1
factorial.
1
1
factorial.
factorial.
factorial. Good, good. Now we have to break this one down. Okay. Now what is 7 factorial? We'll do what? 7 times what? Times 6. How do we get a 6?
The number after
Yes, we subtracted 1 from
before.
the 7, right?
Yes, please.
Yes.
Okay. We said that this 7 factorial, we can write 7 factorial as what? 7 times what? 6
7.
factorial. Do you believe that?
Yes, please.
Yes.
Yes, we can write 7 factorial as 7 times 6
Yeah.
factorial. Is that okay? Is
6,
it clear?
5, 4,
Yes.
3, 2,
Yes, please.
1.
Right? Remember, is it clear?
Yes, please.
Yes.
Okay.
Yes,
So mean
please.
that 7 factorial is the same as 7 times 7 minus 1 factorial, right?
Yes, please.
Yes.
Is this one too clear? Okay.
Yes,
So now
please.
let's use that one to evaluate the top. The n factorial will be the same as what?
N
N
N
times n minus
n
1
minus
plus
1
1
times
1 factorial.
factorial.
plus 1 factorial. Good. The reason I'm doing it like that is because I want to use it to count icing.
Yes.
Okay, so that this one will cancel this. Okay, 1 factorial is what?
1.
1. So we are going to get what? N over 1, which is the same as what? N. Are you following?
Yes, sir.
Yes.
Okay. So let's go to the next one. N combination 2. Okay. So we are going to N combination 2. So let's go. The same thing we are doing. So N combination 2 is going to give me what?
N factorial
N
over
N
factorial
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 over
over
N
n
squared
minus
minus
2.
n
2
minus 2 factorial.
factorial 2 factorial.
2 factorial.
Good. Okay. Now we have to cancel. We don't want to use a lot of factorials in there. So this n factorial, can we write it in the form where it will contain n minus 2 factorial?
yes.
This one. Okay. Now, do you believe that 7 factorial can also be 6 factorial can also be written as what? This 6 factorial is written up here. Okay, it can be 7 times 6 times what?
6
5
5
factorial.
factorial.
Right?
Yes,
Yeah.
please.
Yes.
Okay, so the n, can we also write the n so that we can include n minus 2 factorial?
Yes.
So what will it be?
N
N
times
times
n
n
minus 1
minus
minus
1
1
times
times n
n
minus 2
minus 2
factorial.
2
factorial.
factorial. Good. All over n minus 2 factorial 2 factorial. Is it clear? Francis and Co.
Mr.
Sunam.
Nketiano.
Yes. Sunam is not clear. Yes, that's why I've said that if it's not clear, stop me before I go. Francis, is it clear? Is it clear? Francis, I can't hear you. Sean Adams, is it clear? Emeralda, is
No,
it clear?
sir. No, sir.
Yes,
Emeralda, is it
please.
clear?
Yes,
Okay,
please.
so let me try and go over for the sake of those who don't get it. Okay. I was saying that, have you seen 7 factorial? Sunam, are you there?
Yes, please.
We can write it as what? 7 times what? 6 factorial. You understand that one?
Yes.
Okay. Or we can also write it as, this is factorial, we can write it as what? 6 times what? 5 factorial.
Yes. Yes,
This one
please.
too is clear. Is this one also clear?
Yes, I understand this one. Yes.
Okay. Or we can also remove the 5 factorial and make it times what? Times 4 factorial. Right?
Yes.
Okay. So let me come back to where I used to be. I used to be here. Okay. So now look at something. This, it means that this 7 factorial is the same as 7 times this 6 is the same as what? 7 minus 1, right?
Yeah.
And then this 5 is the same as what? 7. Okay, so that's the same thing we are doing here. The n is a 7. Okay, then n minus 1 is what? 7 minus 1, and then n minus 2 factorial.
Okay.
Doesn't make sense now.
Yes, please.
So the next one, if you want to do the next, I can do it n minus 2 times what? N minus 3 factorial.
Yeah.
Yeah, it makes sense now, right?
Yes, please.
Sean and Co. Francis, doesn't make sense now. I need to move on. Francis, does it make sense now?
Yes.
Okay, good. Okay, so let me clean this one. So the n minus 2 factorial will cancel the n minus 2 factorial up there, right?
Yes.
Yes, so this will cancel this. Okay, so that will get what? N into bracket n minus 1. Are you there?
Yes, please.
Yes, please.
All over what? 2 factorial is what? 2 times 1. Are you there?
Yes, please.
Okay.
Yes.
Are you seeing some similarities in what the book puts there? Page 191. Look at it. Are you seeing some similarities in the coefficients we are doing? Look at the coefficients we are doing. Look at the coefficients we are doing. Okay, so let's move on. N combination 3 will be what?
N factorial
Factorial over what?
N
n
factorial.
minus 3
N
N
factorial.
Minus 3
factorial.
factorial.
3
3
factorial. Okay.
factorial.
3
Okay, so
factorial.
we'll write this n factorial so that it can include what? N minus 3 factorial. So to be what? N
N
times what?
Times
n
n
minus
minus
1
Minus
1
1
1
times
times
N
n
n
minus
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 2
2
2
times n minus
times
3
minus 3
factorial.
minus 3
factorial.
3
factorial.
factorial. Good. All over what? N
n
minus
minus
3
n minus 3
factorial.
factorial
3 factorial.
3
factorial.
factorial. Okay, so this will cancel this. Okay. Are you following?
Yes, please.
Yes.
So that will get what? N into bracket n minus 1, n minus 2, all over 3 times 2 times 1. Okay. Or let me put the or so that it will look like what is in your book. Okay. Oh, back. Or the 3 times 2 times 1 is what?
3
3 times
factorial.
what?
3
3
factorial.
factorial. All over 3 factorial. This one too. Or n to bracket n minus 1 over 2 factorial. Okay. Are you writing? Are you
Yes,
writing what
please.
we are?
Yes.
Yes,
Okay. So can I go on? I want to bring it back into the original
Right.
equation that we had. I want to come and put this one into the original equation that we had. Okay. Are you there?
Yes,
Yes.
please.
Okay. Now it's left with the last but one term, which is a bit difficult. So let me try and do the last but one term, which will look a bit difficult, but I'm sure we can still overcome it. Okay. So the last one is going to be n combination r. Okay. N combination r. Okay. Okay. Now n combination r. Take your time. Now this is take your time. It's going to be what? N factorial. All about
Over
what?
n minus r factorial.
N minus r factorial. R
R factorial.
factorial. You know what the R is? Do you know what the R is? The R. Will you remember what the R is? Okay. Remember that I was saying that n combination 0. Are you there?
Yes, please.
N combination 0 is how many ways can we write, let's say, if I'm having a plus b all raised to the power 5, n combination 0 is how many ways can I write a raised to the power 5 and there's no b, right?
Yes,
Is
please.
that right? Yes. So it's going to be what? N combination 0, right?
Yes,
And then
please.
the last one was what? The last one was n combination 5. The r can never be more than the what? The n, right?
Okay.
The r can never be more than the n. Is that clear?
Yes, please.
Yes, the r can never be more than the n. So this is the last but one term. I'm trying to do the n over n combination. I'm trying to do this one. Last but one term. That's
Stop
what I'm
wasting your
trying to.
time.
Okay. So now let's look at something. So I'm coming back. Okay. So this n this one, this n factorial is going to be n
25.
times n minus 1, I there, times n minus 2, I following,
Yes, please.
times n minus r plus 1. Okay, then the last one will be n minus r factorial. Okay. The reason why I'm saying r plus 1, I following.
Yes, please.
Hello. The reason I'm saying
Yes.
r plus 1 is that if the n is 6 and then the r is what? 5. The r is 5. Okay. Are you there?
Yes, sir.
The down part is going to be 6 minus 5. Let me do the down part before I do the top part. Then 5 factorial. Are you there?
Yes, please.
Then the top part will be what? 6 times 5.
Of the farm, what you are doing, you are not sweeping.
6 times 5, right? This one is a bit difficult, so I need you to pay attention before you can understand. Okay. 6 times what? The 6 factorial will be what? The top is 6 factorial. 6 factorial is what? 6 times what?
6 times 5.
5. Okay, so the 5, now I want to write it as 6 minus 1. Okay. Times 4. 4 is what? 6 minus 2. Times 3, which is what? 6 minus 3. Times 2, which is what? 6 minus. No, times 2, which is 6 minus 4.
4.
Times the last one. This 6 minus 5 factorial is what? Okay.
This is 40
So it's
minutes,
going to be
idiot.
times. Hey, Sean. Sean. Are you seeing what I'm doing here?
Yes,
Nathan,
please.
Echo.
Yes, please.
Yes, sir.
Do you understand how I did the top part?
Yes.
Yes. Yes,
Yeah,
please.
so it's going to be 6 times. This one is the same as 5. This is the same as what? 4. This is the same as 3. Okay. This is the same as what? 2. And this is the same as 1 factorial. Okay. Look at the last.
Yes,
Look at the last term. This one is supposed to be the last term. Remember, this one is supposed to be the last term. I can't get 0 times 0. Okay. So look at my last batch one term was 6 minus 4. But what is the r? The r is 5. Okay. So this one is the same as 6 minus 4 plus 1. This 6 minus this last batch one term is the same as 6. The r is 5. Okay. The r is 5, so it's going to be 6 minus 5 plus 1. This 4. That will always be the last term. Okay. That will always be the last but one term. The last but one term will be n minus r plus 1. The last but one term will be n minus r plus 1. Then the last term will be what? N minus R. Are you there?
Yes, please.
Okay. So this is what the top is going to give us. It will be left with the down. So let me try and do the down part for you. We are doing all of this because we want to come up with a coefficient. That's the binomial theorem. It's like I'm proving the binomial theorem to you. Okay, how we came by that long equation. So all over n minus r factorial r factorial. So this n minus r factorial will cancel this n minus r factorial. So my last but one term. This one I may not always need. It's going to be n to bracket n minus 1, n minus 2, then up to n minus r plus 1 all over r factorial. Okay. It's just like the way we did the other one, just that this one we didn't have numbers, so it was becoming difficult for us. Are you following?
Yes.
Okay. And the last one, n combination r. See, the last term was what? This last term was what? N combination n. Okay. So n combination n is what? N combination n is what?
N factorial
Over n minus
minus
n
n
minus
factorial
n factorial.
Okay, so I'm going to get what? N factorial, n minus n factorial is what? 0 factorial.
0 factorial.
N factorial. Cancel 1, 1. You are going to get 1 over 0 factorial, which is what?
1.
1. 1 over 0 factorial. Okay. Okay. See, so you see the first time we are getting the coefficient to be 1.
Yes,
N
please.
combination 0, we are getting 1. N combination 1, we are also getting 1.
1.
You remember Pascal's triangle? What numbers begin and what numbers end?
1.
Yes, Pascal's triangle. 1 begins and then what? 1 ends. Are you there?
Yes, please.
Okay. So now what I've been able to do, I'm just going to insert it back. Okay, from n combination 0, I'm going to insert it back into the former equation that I did. Okay, so pay attention. Just pay attention. Let me go back. Let me zoom in. Let me zoom in here. I think when I zoom in better, it will be good. Okay, so n combination 0, what did we get for n combination 0? Those of you who wrote it, n combination 0, what did we get?
N combination, we had 1.
Okay, so let me rewrite it on a new page to make sense rather like that way. So let me change. Okay, good. So a plus x raised to the power n. Okay, it's going to give us what? N combination 0, we had 1. Good. So let's come back. 1. Then what? A raised to the power n, right?
Yes, please.
Okay. So if we multiply by 1, we still get what? A raised to the power n. A raised to the power n. Then we'll go back. N combination 1, what did we get? What did we get? I have to come down. Okay, let me come down. N combination 1, we had what? N, right?
N. Yes, please.
N combination 1, we had n. So let's go to so it's going to give us n. Then a n raised to the power negative 1 x. So I write it. So a n raised to the power negative 1 and then x. Are you following? Are you following what I'm doing?
Please. Yes, please.
Okay. I'm trying to come to where your book, what your book gave you the last. Then n combination 1. The next one is n combination 1. N combination 1. Okay, then n combination 1. So we'll go to n combination 2. What is n combination 2 giving us?
N into bracket n minus 1.
All over 2 times
2
1.
factorial.
Yes, all over 2 factorial or 2 times 1. Okay, so n into bracket n minus 1. Remember, it's giving us what? n into bracket n minus 1 all over 2 factorial. And go back, it is what? A raised to the power what? N minus 2 x2, right?
Yes, please.
A raised to the power n minus 2x2 plus. Let's go. The next one was what? So the next one would have been what? N combination 3, right?
Yes. Yes.
The next one would have been n combination 3 gave us what? N into brackets n minus 1, n minus 2, all over 3 factorial, right?
Yes,
This. Okay, so the next one is going to be plus n into bracket n minus 1, n minus 2, all over what? 3 factorial. Then our n will now become n minus 3, then x raised to the power 3. Are you there? Are you there?
Yes, please.
Okay. So what it means is that n combination 4. N combination 4 means that this one, it will become 3. It's just simple. So it's going to be n into bracket n minus 1, n minus 2, then we'll add another one to it, n minus 3, all over 4 combination. Are you following?
Yes, please.
So we'll just add another 10 things. So here will become a n minus 4 x raised to the power 4. Are you following?
Yes, please.
Okay. Then our last but one term. Okay, there can be many terms in there, but our last but one term. What will our last but one term be? Let's go back. Our last but one term. Our time is up. Yes, our last but one term. N combination R was what? This was what N combination R was. N bracket N minus 1, N minus 2, dot. Okay. So let me go. N into bracket n minus 1, n minus 2, dot, n minus r plus 1. Okay. All about what? R factorial. Then let me come back. Our a, what about a raised to the power? Okay. Our a was what? A raised to the power what? N minus r. Last but one term. A raised to the power what? N minus r.
N minus r.
X raised to the power r. Okay. Yes. So okay. So a raised to the power n minus r, x raised to the power r. Then our last term was what? N combination n, right? N combination n was what? 1. N combination n was what? 1. Let me go back and show you. N combination n was what? 1, right? N combination n, it was what? We had 1. We had 1 here. Okay, then it's what? X to the power n. Okay, so 1 times x to the power n is going to be what? 1 times x to the power n is going to be what? X to the power n. Yeah. Now I want you to compare this with what is in your book. Compare this with what is in your book. It's too. Yes. It's too. Can you compare this to what is in your book? Page 191. Page 191. Binomial theorem.